Hello everyone, my name is Guan. I'm from Dalian Polytechnic University. The topic of my presentation is high-throughput visible image transmission design based on XCT root 3D reconstruction system. Background of my research. Part 2. The experimental analysis we have proposed in the paper. Part 3. Circuit design. Part 4. System transmission test. Part 5. Some conclusions we have got. Part 1. Introduction and background. First, introduction research background. The change of global climate influences the adaptability of plant roots, the soil constructing. For CT image segmentation or reconstruction as a processing end, it's necessary to collect a large amount of data from the host computer and complete process algorithm calculations. The research topic is in situ non-destructive measurement of roots in soil and extraction of root characteristic from in situ root CT images. Second, introduction research topics. In this paper, a high-throughput method of visible light image transmission for the root system 3D reconstruction system of XCT technology is proposed, which provides a kind of upper and lower computer for specific high-throughput root system scanner in the future. The design of visible light image data transmission utilizes the characteristics from fast data transmission speed and large throughput of visible light for image transmission, which can effectively reduce the time of image data transmission between the image terminal and the lower computer, and reduce the research time cost of the overall system. Third, introduction overall design structure. The overall system structure is divided into two parts: the transmitting end of the upper CT imaging and the lower reconstruction. The block diagram is shown in this figure. The CT imaging terminals image information communicated through the serial port, and the signal modulates to the LED white light resource. The visible light is transmitted through the optical channel and received by photodiode. The signal is demodulated and sent to the serial port of the lower computer to recover and display. Part 2. System Principle Analysis. First, the choice of white LED. In the high-throughput visible light image transmission circuit, device selection and the overall design of the circuit in the future will directly and indirectly affect the performance communication. The first line is the spectral curve of fastfall imaging. The second line is the fastfall curve of the single blue LED imaging. The third line is the mixed curve of the first and second types. Second, Selection of photo detection diode. The photo detector and circuit construction directly or indirectly affect the communication system performance. So facing the high-throughput visual light image transmission system based on CT root system. This type of photo detection diode circuit we can select these 2 points. First, the photoelectric detection circuit has good linearity and electrical signal is less interfered with by the internal noise of the circuit. Third, the photo detector diode frequency response range should match the bright LED luminous effect as emitter. Third, the response speed is fast. The frequency bandwidth is comprehensive, and it has adapted to the environment of high-throughput transmission of CT images. Fourth, the photoelectric conversion circuit is simple, and the photoelectric conversion efficiency is high. We can see this figure. It's shown the response curve of a typical photodiode. Part 3. Circuit design. First, transmitter circuit design. This is schematic diagram of a white LED drive circuit in my paper. The visible light image transmission transmitter designed based on XCT technology root system 3D reconstruction system consists of 3 parts. The first part is USB communication module. The second part is signal circuit module. The third part is the white light LED drive circuit module. The white light LED drive circuit is the core part of the transmitting end, and its working principle is the convert, the modulate, direct convert signal into the light signal emitted by the white light LED, and the amplified, the modulate intellectual signal. The amplification factor of the amplifier A1 is shown in this schema. OOK modulation is adopted on the main control chip, the purpose of which is to modulate the image battery signal stream from the front end of the LED driver circuit to the white LED, and emit high frequency flashing optical signals. OOK modulation is a optical communication modulation technology. It controls the transmission frequency according to the amplitude of the signal. Second, receiver circuit design. This is the schematic diagram of the receiver circuit. The visible light image transmission receiver design based on the XCT technology root system 3D reconstruction system consists of 3 parts. The first part is silicon photoelectric detection circuit. The second part is receiving amplifier circuit. The third part is communication module. The amplification factor of amplifier A2 is shown in this schema. The overall system principle diagram of the receiving end shown in this figure. Among them, R7 and C5 composed of low-pass filters. Two functions realized in the circuit of this design. One is to amplify the photo detection diode electrical signal, and the other is to filter. RF2 and CF form a feedback circuit, and an operational amplifier form a voltage negative feedback amplifier circuit, making a circuit have an advantage of low noise and frequency bandwidth. The feedback circuit controls the receiving end. Amplifier circuit's frequency response at upper cutoff frequency responsive by F. So, this is the formula for the upper bound cutoff frequency F. Part 4. System Transmission Test. To simulate the CT image terminal, connecting at the transmitting end, connecting the USB to upper computer and power on the transmitting end, connected the USB to the lower computer at receiving end, and power on the receiving end. Under normal lighting conditions in the library, the transmitters and receivers faced at the center distance, and the bit error rates at the distance of 10 centimeters, 20 centimeters, 60 centimeters, 40 centimeters, and 50 centimeters, and the high voltage signal at the receiving end counted separately. It can be seen from Figure A that the high-level output at the receiving end of this system is related to the communication distance. The voltage values of the output signals at the receiving end at different distance sampled. It can be seen from the change curve that when the communication distance is less than 40 centimeters, the output voltage does not change much with distance. When the communication distance is greater than 40 centimeters, the output voltage dropped smoothly. The Figure A can be inferred that the best communication distance from this system is within 40 centimeters. It can be seen from Figure B that when the communication distance of this system is less than 60 centimeters, the bit error rate decreases with the increase of the communication distance. When the communication distance is greater than 30 centimeters, the bit error rate increases with the communication distance increase. After experimental analysis, the best communication distance in this system is 30 centimeters. In this picture, we can see the transmission diagram of the transmitting end and the receiving diagram of the receiving end. Under the optimal communication distance of 30 centimeters. Figure A is the original image of sender. Figure B is the image received by the receiver. Figure C is the root characteristics. The white points are the roots. Part 5. Conclusion. This design provides a high-throughput root system 3D reconstruction system based on SCT technology to give a design solution for the transmission of visible light image from upper and lower computers. Compared with the image transmission bus scheme of the traditional medical CT machine, this design takes into account the high-throughput image information transmission, and the total cost will be greatly reduced. For future high-throughput plant roots phenotype image data research, a new transmission option is provided, and it can be used on the specific root CT scanners. That's all for my presentation. If you have any question, please feel free to contact me. Here is my email address. That's all. Thank you.